if the size is more than critical size, the chain reaction continues. Suppose if the size is less than the critical size, then the chain reaction terminates. What is multiplication factor? It is the ratio of number of neutrons present at the beginning, initial stage of a particular generation to the number of neutrons present at the beginning of previous generation. The nuclear fusion reaction takes place at a very high temperature and hence it is also called as thermonuclear reaction. Hello everyone, welcome to session 4 of chapter 13 Nuclei. This is Swati from Department of Physics, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear children, in the last session we have studied about the radioactive substances and the properties of those substances such as half-life and mean life. So in today's session, we shall study about the nuclear fission and fusion reactions. So what is the meaning of nuclear fission reaction, or nuclear fission means what? It is nothing but the process of splitting up of heavy nucleus into two or more lighter nuclei of comparable masses. You can see here a heavy nucleus, it is undergoing disintegration process, it is undergoing splitting process. So after splitting up, it is divided into two lighter nuclei. Again, it will undergo division further with the liberation of enormous amount of energy is called as nuclear fission reaction. So let us understand nuclear fission with an example. See here, when an uranium-235 atom is bombarded with a slow neutron, it gives rise to an heavy nucleus, that is uranium, and in a short interval of time, this uranium splits up into two fragments, that is barium-141 and krypton-92, with the liberation of number of neutrons, that is 3 number of neutrons with an enormous amount of energy, that is energy. So the energy emitted per fission of uranium nuclei is about 200 mega electron volt. Here the heavy nuclei of uranium, it is bombarded with a slow neutron, then it becomes a heavy nucleus of uranium-236. It undergoes splitting process which will give rise to two fragments. One is krypton, the other one is barium, with the liberation of large amount of energy. So the amount of energy related or released in this process is about 200 mega electron volt. So this is process called nuclear fission. So next we have nuclear chain reaction. What does it mean? So the nuclear chain reaction, as the name suggests, the chain reaction is nothing but it's a self-sustaining process in which number of neutrons produced multiplies rapidly. How does this multiplication takes place rapidly? Due to nuclear fission reaction. So until the whole fissile material gets disintegrated, the heavy nuclei gets splitted up until the whole radioactive substances or whole material or the whole fissile material gets disintegrated. This splitting process goes on and hence the name chain reaction. So we can understand this terms or the sentence with the help of this following example. Here the heavy nuclei is undergoing disintegration by splitting it into two constituent nucleus. Again, this one, each single nucleus is getting splitted up and this process continues until the whole fissile materials gets disintegrated and hence the name called nuclear chain reaction. So in the nuclear chain reaction, we need to understand two important terms. One is critical size, the other one is critical mass. What is critical size? It's a condition. So what condition it is? The chain reaction may be sustained chain reaction if the size of the fissionable material must have a particular minimum value. So the minimum value that is required for a fissionable material to undergo sustained chain reaction is called as critical size, at which the loss of neutrons is exactly equal to the production of neutrons. If the size is more than critical size, the chain reaction continues. Suppose if the size is less than the critical size, then the chain reaction terminates. So there must be some minimum value for this sustained process to goes on. Suppose if the size is more than the critical size, then the chain reaction continues. Suppose if the size is lesser, then the chain reaction terminates. What about critical mass then? The mass of the fissionable material corresponding to critical size is called as critical mass. The next very important term to understand is the multiplication factor, which is denoted by K. So what is multiplication factor? It is a ratio of number of neutrons present at the beginning, initial stage of a particular generation to the number of neutrons present at the beginning of previous generation. So in this example, we can understand multiplication factor. It's a ratio of number of neutrons present in the beginning of one generation to the number of neutrons present in the previous generation is called as multiplication factor. As I told, it is denoted by K. When K is equal to 1, the rate of energy released is steady, it's constant, and the chain reaction is said to be critical. Suppose if the value of multiplication factor is greater than 1, then the rate of energy released increases and the chain reaction is said to be supercritical, because the energy released will be more and the chain reaction becomes supercritical, and this condition may result in explosion of the reactors. If the value of multiplication factor is less than 1, then the rate of energy released decreases and hence the chain reaction is said to be subcritical. So here chain reaction will eventually die out. It will decrease, the release of energy will decrease and gradually it will be terminated. Eventually it is die out. So let us now discuss about another important concept called nuclear fusion. So far we have discussed about nuclear fission. So what is fusion reaction? Fission is the process of splitting up of heavy nuclei, where fusion is to fuse them together, which means the two lighter nuclei together forms a heavy nucleus, and this process is called as nuclear fusion. So it is a process in which two lighter nuclei fuse to form a heavier nucleus with the liberation of an amount of energy is called as nuclear fusion. You can see in this example, two smaller atoms, they are fusing together to form a larger atom or the larger nuclei, but in this process also there will be a liberation of a large amount of energy. So you can observe in this reaction also, deuterium and tritium are together fusing to form a helium nuclei with the liberation of number of neutron plus an energy. So this process of fusing together to form a higher or the heavier nuclei is called as nuclear fusion. So this process is completely opposite to nuclear fission reaction. So this can be understood with the help of an example. When two deuterium nuclei, you can see here 1H2 are deuterium nuclei. When they are fused together, they form helium nucleus and the energy will be liberated, that is of about 24 mega electron volt. So the energy emitted per fusion of nuclei is 24 mega electron volt. So the nuclear fusion reaction takes place at a very high temperature and hence it is also called as thermonuclear reaction. So this is the process what exactly we can observe on the solar surface or on the surface of sun. It undergoes nuclear fusion reaction and generally it takes place in a very high temperature, hence it is called as thermonuclear reaction. Let us now quickly go through the differences between nuclear fission and fusion. So nuclear fission, as we all know, it is the process of splitting up of heavy nuclei to form a two or more lighter nuclei of comparable masses along with the liberation of enormous amount of energy. It is called as nuclear fission, and the opposite of this is a fusion, which means the process in which two or more lighter nuclei are combined to form a heavy nucleus with the liberation of energy is called as nuclear fusion, and the energy released per fission is more. In case of nuclear fission reaction, the amount of energy released is more, but in case of nuclear fusion, comparably the energy released is less. So energy released per nucleon in case of fission reaction is less, but it is more in case of fusion reaction. And the next difference is nuclear fission can be a controlled reaction, where in case of nuclear fusion, it cannot be controlled so easily. So nuclear fission takes place at very low temperature. As we have discussed just now, nuclear fusion is called as thermonuclear reaction as it takes place at very high temperature. And the products which we get from nuclear fission are harmful. They are radioactive in nature. So radioactive substances are harmful, where in case of the products which we get during nuclear fusion reaction is harmless. So generally, the principle of atom bomb is nuclear fission reaction and the principle of hydrogen bomb is nuclear fusion reaction, which undergoes nuclear fusion. So these are the basic differences between nuclear fission and fusion. So in this session, we have learnt about two processes, fission and fusion with an example. So what is a chain reaction? And this is the end of chapter nuclei. So in the next session, we will come up with another new chapter. Until then, keep learning all of you. See you all in the next session. Thank you.